All right. Welcome back, everyone. If this is your first time joining, hi, I'm Agent Ultra, and this is a stream where I make stuff in Haskell. And we've been working on a project to make a clone of the popular game, or maybe formerly popular game, Asteroids. A good first project if you're just getting into game development and want to learn about programming and making games and stuff like that, because it's pretty straightforward and pretty simple-ish. I'd say it's a medium-sized game to try and take on, but it's not too bad. So we're doing it in Haskell because I had a lot of questions about, like, is Haskell viable for game development? It turns out that yes, it is. There are commercial games released in Haskell on the Steam store, and this project's coming along pretty nicely as well, if I do say so myself. So this is what it looks like so far. If you haven't seen it before, I'm just going to go into my project director here, Asteroids, and I'm going to run it with my little stack exec command. Show you where we're at. And where did the window? There it is. All right. We have this kind of little ship. We have a little, we added last week this little hello text texture, which we're going to expand upon this week because we need to display the score and menus and stuff like that. So we're going to need to use a little bit of text. And then we can like shoot little bullets. And we have a little asteroid here with its collision box being rendered currently, so we could test collisions and such. And yeah, if we hit it, boom. So this week, I'm going to try and get this score display working and displaying in our nice little text here and make that all work. And then maybe we'll get to menus after that if we can. And then we'll start adding some juicy effects and then maybe call it at some point after that. So we're getting close to the end of the project here is what I'm trying to say, I guess. So there you go. Where do we start? First, I wanted to make sure that I had something about the font that we're using. So whenever you're using assets from the internet or from somewhere else that you didn't make yourself, obviously check your licenses, make sure you give attribution where attribution is due, all that sort of stuff. It's not a huge deal here. It's an open source license, the open font stuff. And we should add a note about it in our README file, at least. Let's do that. Noticia font from Google. It uses license under OFL. And the link to the OFL is, well, to the page about it, and like to get to the OFL stuff is from there. So just got that quickly. Pretty simple. Okay, just add that little commit there. And we're good to go. So let's dive in. I'm going to pull up our game engine code, Asteroids game. So our Hello World texture stuff. This is going to be kind of interesting if you're into that sort of thing. We have all of these. We have to render the text to a texture first. And we have to know this, so then we have to know this when we render a texture, right? We're gonna get like a rectangle, right? With some data in it. And then our data is going to be like the rendered text, what you see on the screen, and that hello thing. And in order to render that texture, you have to give it a rectangle. In order to render it onto like our screen, buffer there. And that kind of means that we have to figure out the size of the texture, because a rectangle has like a length and a height. And so we have to kind of figure out the size of what that rectangle is going to be before we can render the text. Right. So we can figure that out dynamically-ish, I think. All right, when we load our, so when we create the surface here, the surface in SDL parlance, which is the media library we're using for displaying graphics and things like that, they call it a surface. It's like just basically you think of it as like a big array of bytes. All right. Each really like pixel data is what's in it. That's what this V4 is one of those pixel data where we have like RGB and an alpha. So it's 4 numbers: red, green, and blue, 0 to 255, and then an alpha. 0 to 255. The alpha is like how transparent it is, that sort of thing. So this font.solid function renders that text to this surface. And then texture, this create texture from surface function, creates the texture. Now the texture is what SDL2 uses to like render to the graphics card. Right? And surface is this like in-memory array thing. This texture is like this special data structure, also kind of an array. That's going to go to our graphics card and be, if we have the right options set, blah, blah, blah. It's going to like hopefully be hardware accelerated and yada, yada, which is all fine and dandy. But this copy function here is what renders the texture to the rendered scene. Right, copies this texture. And so we have to pass this rectangle in order to get the size of the square that we want to render. So right now I have it hard-coded 10 to 10, that's the position on the screen, and then 100 by 100. So basically I'm rendering a square. All right, and when we check that out, when we run the game, you can see it doesn't look very good. It's all kind of squished in there. Because the width of our font is much bigger. When we initialize the font library, we have to tell it how big it is. Font.load. We tell it 32, right? So hello has a certain number of characters in it, the text that we made. If we multiply that out by 32, this is probably not a monospace like regular square font, so like there's going to be spacing things. So we have to figure out like how wide that is basically to get it to render like as it's supposed to. If I make this much smaller, it should fit in our square. Maybe I make it a size 12 font. And if I quit out of this and build our project again, look at that going. File watch. So this is just gonna, sorry, I go to my project directory here. Do that. So just rebuild our project, get that going. And once that's done compiling, we can run it. And so with a smaller font size, it should render on that texture without any, hopefully without any squishing, but it looks like it's not. It looks like it's actually rendering worse. I wonder why that is. Maybe my understanding of the target rectangle in this API is a little bit off here. Let's increase, I think this is the height and the width. Let's make this 2 or maybe like 300 and see if that makes it a little better. It's stretching it out. That's what it's doing. So yeah, I think in order to get it to render proper, we actually have to like The target texture has to be like just the right size for what we need here. So let's see how many characters we got here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So a quick little math here. Let's go scratch buffer. Line 13 times, what do you say, 12? Should be 156. So with spaces, let's just try 156. And height, well, let's see if that renders nice and crisp. Okay, not at all. All right. So clearly my thinking about this is way off here. Let's look at the API documentation then. SDL2, so SDL2 is the media library. It's written in C. We're using Haskell, of course. Wraps around it. We're going to look at the Haskell documentation for this. We want SDL font. Okay. Point size, this is an int. Point size based on 72 dpi to load the font as, translates to pixel height at a certain point size. Okay. Okay, that's all fine. Rendering, okay. Yeah, so the text isn't going to be smooth, as apparently according to the documentation. That's fine. Hey, Lemnine, you imagine the first 12 days will be spent attempting to figure out what a monad is. Yeah, I mean, it takes about 12 days-ish. So hinting, set kerning, monospace, blah, blah, blah. Okay, height should get our maximum. It'll be useful. Oh, cool. Handy is monospace. Can tell if a font is monospace. So I was thinking about the square letters. Like that's a monospace font. Each letter or glyph that you're rendering is the same fixed size. So when you're trying to figure out the width of the surface that you're going to get when you render out a piece of text, it's pretty straightforward to calculate. Okay, so that's... No, we want the video library. I think we need the rendering one. So copy is what we use to copy the texture. So copy a portion of the texture to the current rendering target. So we're using this rectangle here. This is the destination rectangle to copy to, or nothing for the whole rendering target. The texture will be stretched to fill the given rectangle. Okay, so that's what I think was happening. We were rendering the texture with copy to this rectangle here. If we make this quite big, it was kind of stretching things out. So the texture will be stretched to fill the given rectangle. And then nothing copies the whole texture. So basically, we need to figure out a way to calculate how big the texture, this rectangle should be. think if we just make this nothing, it's going to stretch to fill the whole rendering target. Right, like this, like hello, all the way across. We don't want that. Although that's not too bad either. You know, it's fun. It's fun. Okay, so let's write a function to render a string somewhere on the screen. Called render text. And what do we need to do that? Well, we're going to need our font. The text to render. We'll need a position to render the text into. So we'll do a v2 of... I think we're ultimately going to need cint, but we'll just make it nicer on ourselves and do that way with ints as the argument, and then we'll do an IO operation. Hello, oil-rich short. I don't want a promotion, thank you all. You shall be banned. Goodbye. Thanks, Jeffrey Thickcoms. Much appreciated. Okay, so we need a font, the font to render with, the text we want to render. Maybe I should change the order of the arguments here, just because I don't like that. Text first. Position, font last. Hey, Swarm Collective, welcome back. Nice to see you. Thanks for dropping in. So we'll call this txt position and font. Okay, I'm going to steal much of this code from there to put in our function. Oh, we're going to need a renderer. I think it's going to be under, I think I've imported sdl.renderer. And by the way, if you're just tuning in for the first time, this is like a learning stream too. So if you have any questions and you want to know what I'm doing or like what certain things mean, please feel free to stop and ask. Happy to help out. Oh, maybe I meant font.font. I don't have text in scope. Well, that's no good. Let's import it. Import data.text. Just the type for now. Okay. Okay. So then we just have to fix this code here to get it compiling again. I don't have a game state font variable in scope in this function body, but I do have FNT. That's our font. So I'm just going to replace all instances of game state font in here, which I think is just the one. FNT to make that go away. Okay, this error is cannot match type unit with IO unit. Oh, because I didn't bring in that argument to here. Renderer. There we go. That should go away now. There we go. Yes. Okay, this type error here. Game state renderer. We don't have game state renderer. We just have renderer. And that should make that go away. And this as well needs to be rendered. Yes. There we go. Okay, so we didn't use text and position, which means this isn't quite right yet. That's just because the what I copied didn't use it. So I'm going to pull this out here and call render text like this, and we'll give it a v2 int of like what we had before, kind of 10 at 1010. The font, game state font, and the renderer, game state renderer. Okay, so then we just have to figure out how to calculate all the arguments to this rectangle to get it rendered the way we want to do this. Reminding ourselves that font.cell is not going to produce the most smooth text. That's just quick and dirty, which is fine enough for our purposes. I just wanted to not be so stretched. So I think we're going to need some of our font size calculation functions from our font library, probably, to do that. Yeah. Right, v2 sdl.p v2. We could just give as position and hardcode something ridiculous. I have to convert the position to cint. So that's cint thing is just a C thing. C being the programming language that the SDL library is actually written in. It's not written in Haskell. So we need that function there. Int to cint is from integral. From integral. That compiles there, and now the only part we're not using is text, which we're going to use to replace this hard-coded hello string. And now we've used all of our arguments in our function, equation, formula. And now we just have, what do we have? We have a warning. Oh, our package doesn't actually have data.text as dependency. Okay, so some annoying package stuff, not too big a deal. I'm going to go on my package.yaml, and I need to add text here as a dependency. And there we go. So success, we have compiled. And now when I run it, yeah, we got our little hello world string kind of all squished in there. Okay, so next part. Let's figure out, so I think the height value we know we can get from that function in the font library that tells us how tall or how big it is, right? That's loading the fonts, rendering attributes, get style, set style, outline, set outline, hinting. Is monospace, height. So lines, what's line skip? Get the recommended pixel height of a rendered line of text given font. It's usually larger than what height would return. Okay, so we want maybe line skip. Line skip function, it sounds like. So we get the actual height of what we need to render at. Okay, so for line skip, we just have to pass it in the font inside of some monad IO m event, which we can do as if you replace m with IO, that's basically what we're doing here. So we should go font height, maybe line height. Font dot line skip, and our font FNT. Works. So now we just need to use line height, and let's use it here. Okay, and line height is an int. Haskell wants us to make sure this is a C int, so to convert line height to a C int here with from integral. Okay, and we're good there. Let's check it out. Okay, well, not quite what we want yet, but I'm not giving up. So if that's the right line height that we need, then 200 pixels is probably not what we want there. How do we figure out how wide our texture is? Maybe we can get that from the surface. It's an attribute of the surface. Let's search for that surface. Surfaces, creating, destroying, state, dimensions. That sounds like what we want. Oh, perfect. Retrieve the width and height of a surface. This might be exactly what we need, actually. We don't have to calculate this on our own. If, so long as the font library, when it creates that surface, is not creating like a super large one. It's creating it just for the rendered text. Let's give that a shot. That might fit in here. So let's put a little hole there. The function takes the surface in and some monad returns our v2 of cint, which will plug in nicely in our hole. Put a little hole there. So I'll call it hello dims. And SDL dot surface dimensions of hello surface. Okay, so then we go back to our hole. And so if you look in this error here, valid hole fits, right? Includes hello dimensions of the variable we just made. It's just the right type to fit in there, so we can just slot it right in. Hello dims. And then apparently we don't need line height anymore. Bye-bye line height. It was nice knowing you. For real. Oh, that's much better. Okay, that's what I want. Again, not super crisp, but it's the quick and dirty method. So that's fine. Cool. All right, so we should be able to render this wherever. So then let's now make a text string. We have the game state in place. Let's make this the game score. game state score, I think we call it the variable. So that's an integer. We have to convert it to text. We could just show it. And then convert the string to text. And that would be the cheesy way of doing it, but it'd be fine. Let's just do it the cheesy way so that it works. And we know that it works. Because I'm not above a little cheese every now and again. So, and then we need the text function. I'm going to leave a hole for that now because I'm going to go up here. Import data.text. Or sorry, qualified as t. And then we'll jump back over here. And then we have t.pack as the function. All right. That should render the game score, which is currently 0. And when I blow up this asteroid, it should be 1. When I blow up this asteroid, it should be 1. There we go. It is now 1. I've got a score display. There we go. Quick and dirty. Gotta love it. All right, push it, ship it. Let's go to the Steam store. So create a little commit, add a score display. There we go. Okay. Now, supposing I wanted to display that a little bit nicer, so it wasn't the quick and dirty method, how do I make crisp text? Font library. Okay, shaded. Use the slow and nice, but with a solid box method. Renders slower than solid, but in about the same time as blended. Results in a surface containing anti-alias text of a foreground color, surrounded by a box of a background color. This surface will blit as fast as the one from solid. Blitting is a pretty old school term, from when back in the days when SDL 1.2 was not hardware accelerated, and it was all software based. Where we would blit big arrays of data to buffers and swap them into the video buffer. Yeah, that's still alive here today, but still pretty fast. Fast enough. I haven't done a ton of text rendering, as you can tell, from my lack of knowledge of this stuff, but yeah. It's tricky. Rendering text on a screen it's pretty tricky. Pretty tricky. Yeah. The good old Win32, yeah. Like, I mean, you look at some of the rendering code in like the Mozilla source code for like Firefox just to render all the text you see on the web. Woo! Fun times. It can be very interesting when you get down to it. All the metafont stuff was really cool. This was like Donald Knuth is like one of my heroes. I love this guy. I don't love him, but like I really appreciate his work, and I adore it. But metafont was something he invented to display fonts. like typeset fonts and stuff. Pretty cool stuff. But like to do it, it was like a whole thing. So imagine that. Go look it up. It's pretty neat. Anywho, if it's not, yeah, let's try this sol. Get rid of solid. Try shade. Replacing that with shaded. Let's see if that renders a little better for our game. Before I push this up, I should probably refactor this code a little bit because like hello dims is a weird variable name to be using in rendered text. Anyways, shaded. Yeah. Shaded needing other thing. Font, color, color text. Okay, so we have to pass in some colors to use shaded. 2 colors. All right, the foreground color, I assume, and the background color. All right, okay, so foreground color, white. Currently, our background color is black. That could change depending on the frame and all these other kinds of things in our game. So let's just we'll just hard code these as 0, 0, 0, 0. Oh, sorry, 255. It'll also be 0, I think. So that'll compile again. If we wanted to be a little bit fancier with our render text function, we should probably make these into parameters. So you can change that. I don't think we need anything. So you can see almost, yeah, it draws the box. Hard to see probably with the stream compression and stuff, but if you look closely, the line from the ship is being written over. Right, there's an actual box there. So it's rendering this. When it's rendering the text, it's rendering the whole, filling in the whole background as well to get this smoother looking 0. So I blow that up and renders the 1. So yeah, it's a little bit smoother looking. Make it a little bigger. Let's load our font in a little bigger. Where do we do that? Load here. Let's go back to 32. Yeah, there you go. Now you can see a little better. Right, over, which is fine. Right. There we go. 1. All right, so we actually wanted to render like a nicer little score box for our UI, so it doesn't look like kind of weird that the ship is being kind of occluded by this one. We could do that, or we could like make like a top bar area so we wrap around at the top of the things below the UI. You know what I mean? But it's probably okay to have the score just kind of floating there. Again, this isn't actually going on Steam. I guess just a learning project, so it doesn't have to be perfect. Yeah, there you go, scoring. Okay. That's enough of that. Let's just do that quick refactor. Fix these names. Here, rename hello surface to text surface. And hello dims to text dimensions, dims. And hello tech. Sorry, Haskell cat. to text tech. Many games zero pad the score, so it was always in the same place, regardless of length. Yeah, right? So, like, and some even emulate those fixed width, like, physical displays that we used to have on, like, pinball machines and stuff. Well, I mean, pinball machines still exist, right? You can only have, like, 9 digits of score, for example. And if you went above that, it just displays as 9999999. That way you get a nice fixed size for the score. We could do that too in our game, or we could just let it kind of go. Yeah. I mean, theoretically, depending on the size of the texture and the width of the screen and all that, you could just keep playing this game, and if you're super awesome at it and never die, you'll just keep making that score bigger. Then why not? Could display it, or just be like, you win. That's it. Right? Make it just go off to the edge and just keep going and going forever and ever. Or you make it wrap around, and so your score, the higher your score, the more occluded your area gets, right? So then it becomes harder and harder and harder because the less you can see what you're doing until you die. Ah, now the score's interfering with it and making the game harder. Whatever you want, man. It's your game, right? You do that too. Woo. Yeah, yeah. I think with our game, like, it's not going to be too bad because we're just like rendering the textures, like rendering the text like this for that. This is like a long down the road kind of thing. If you're building like an engine and stuff, you might want to like pre-render all of your, or as much of the strings as you can, like especially static strings that don't change very much. Pre-render them out, and then you can just load them as assets. It'll be kind of quick like that, but that's all optimization stuff and things like that. I don't think it's not gonna be a big deal for our Asteroids clone that we just do it this way. So it's fine. Cool. So what should we work on next? Now that we have the score display going, stage that. Fix the code. Yo. And we'll just rebase this interactively, squash that up, and make it as if I just wrote the code perfectly the first time. Rebase. Much love. Okay. What should we do next? UI? Menu? Why don't we try that now that since we're working with string textures and we have our render text function. Okay. So if we're going to do this, then we have like 2 states to our game. All right, we have the menu state. We have the game where you're actually playing. And then you have maybe like a game over screen. We display kind of like the final score. Respawn the asteroids. Oh yeah, that's a good one. Song collector. Respawn the asteroids. Yeah, let's flesh out more of the game stuff before we get into that, for sure. Okay. Okay, so I'm gonna let's mess around with our asteroid here and make our small asteroid look a little better. I don't like the shape of that. Our little pointy asteroid here. So that code is And render asteroid. No. We define that as somewhere. Max asteroid, update asteroids, render asteroids, init game state. There. This is where we construct our asteroid. Yeah. So I'm going to mess around with these points. The asteroid points structure here is defines like the different. So if you imagine the asteroid is like a. Here, let me draw this out actually. About. All right, we have a point where the position of the asteroid is. This asteroid points structure is a group of 6 numbers. So we're just hard coding. We're just saying asteroids can have 6 points on them. We're defining like the polygon around the asteroid that gives it its shape. So something like this. Oh, I'm drawing with the mouse here, so forgive me. 1, 2, 3, 4, 5, 6, something like that. And the rendering code like just walks around those in like kind of a circle and just draws straight lines between them. That's how you draw an asteroid in this game engine. So what I'm going to do is just mess around with these a little bit. Bring this one in a little bit. 21 seems a little bit much. Let's make it 15. 23 seems a little bit much. Let's make it 17. Let's say. And we'll see how that looks. Oh, it wasn't the point I was thinking was. That one must be this one, 49. So let's leave 23 and 21 alone. Bring 49 in a little bit. And each of these points in the asteroid points, that's a little better, are relative, are offsets from that center point in the middle that these are all rotating around. So let's see, that's the Y offset. Something like that. So that recompiles, reload. Too bad, not too shabby. Could be a little rounder. Let's bump this one out a little bit more. Bump this one out. It's forced to rebuild, just make sure. Yeah. 0 is fine. Yeah, let's do that. Okay. It's okay. It's a pretty squarish asteroid, but it's fine. It's in the hitbox. It's good enough for demonstration purposes. Perfect. Okay, so let's get rid of the hitbox that we're rendering. Render asteroid. rid of the B-box stuff. Get rid of that. Yeah. That's not done yet. Compiling. There. Okay. How? We don't need that anymore. So fix that. Yeah. Okay. Perfect. All right. Remove asteroid hitbox rendering. Done. Okay, so how are we going to handle... So handling the collision for the small asteroid works. It just disappears and increases the score. We could probably just relay like a little animation there or something, maybe. But we also need to spawn new asteroids on occasion. In our game design, we can spawn them on a timer. So we just keep spawning them at some interval, right? And then the goal of the game then for the player is to like try and keep up with the pace. We can like have like a difficulty curve that increases as the score goes up, you know? And then as the score goes up, the chances of you spawning a large asteroid, for example, on that timer are higher. Kind of making for a frantic play until you can't play no more kind of game and see how far you can get. We can respawn when you destroy them, make it a more chill game. So we can, when a destruction event happens, we can decide to update the game state and say, okay, let's spawn in a new asteroid. Or we could just spawn them in randomly. Just at this point in time, there's a 2% chance we'll spawn in a new asteroid. I haven't really decided which way to go. Let's do it on a regular timer. Or we should do large asteroids first. Yeah, let's do large asteroids. So we have small asteroids, large asteroids, because then we can do the collision handling for large asteroids, which should be different from the small asteroids. Because then they'll spawn in four smaller ones. Okay, so how do we do large asteroids then? This is our data structure asteroid for defining an asteroid. Right, let's look at it. It has points, it has a position of velocity, of rotation, speed, and whether it's dead or not. No indication whether it should be a large asteroid or a small one. Swarm Collective, yes. Once the build completes, the executable is available in the place that stack is configured to keep it. So once the rebuild is done, I can go stack exec asteroids and try out the new build. There is a command to tell stack. I think there's a command to tell for stack to tell you where that build is kept, and I think you can configure it. But I haven't really had to mess around with that a whole lot, so I'm not sure off the top of my head how to do it. Yeah, you can totally execute without stack. So I can take that binary that it compiles and run it on another Linux system. If I wanted to create a Windows build of the game, then I could check it out on Windows, use stack, compile it on Windows, so long as all the libraries that it dynamically links to are available, which is SDL2, SDL2 TTF for the font stuff, And the normal Haskell library, I think Haskell itself only dynamically links libgmp, which should be, you shouldn't have to worry about on Windows, I don't think. I think Stack will take care of that for you. But yeah, you can get those binaries and you can distribute those binaries however you want. We'll get to bundling, I think, maybe if anybody's interested in that for the project. We could do that closer to the end. So how we would actually create releases for our game. That would be that could be something we could do. Able to compile Haskell on a Docker container, but I want to run it on the host machine. That's my questions. Very good. Yeah, you should be able to take that binary as long as it's compiled for the same target that you're trying to run it on. So if you're running a Windows machine, compile it from Windows using Stack, and you should be able to get a Windows binary. I don't know if, so I haven't had to do it. I don't know if Stack can do cross compilation. So if I'm on a Linux machine, can I create a Windows binary? I don't know how to do that. That'd be pretty cool if it could. There are some languages whose tool chains have that built in, like Zig, and I think that's totally cool. With a little tweaking, we might be able to do it. Unless Stack can already do it off the... but I don't know. I haven't done it yet. But yeah, that's something that would be interesting to do, to figure out how to do like all the build setup so that you can get binaries to share with your friends or put on your website or on your itch page. What have you. Okay, so asteroids. We don't have anything that tells us what asteroid is. The big asteroid or a small asteroid? I mean, we want to handle those two cases differently. A big asteroid should have different handling, right? So let's create a structure. Asteroid size. Big or small? Derive our usual eq and show classes. And then we can add a field to our data structure here for asteroid. That just tells us what size it is. So now I'm going to get a bunch of type errors because I haven't initialized the asteroid size field and stuff like that. So let's go fix those. Get our game compiling again. All right, so asteroid here. Let's call this one small. That solves our compile problems. We're back to green again. We're happy. We're good. That's nice. All right, I'm going to want to be able to spawn in asteroids. But I don't want to have to... I don't want to necessarily use the constructor for that, I don't think. So I might want a function to do that. Let's not get ahead of ourselves. Let's just create a large asteroid now. And get it rendering. We'll call asteroid here small asteroid. And then I'll create large asteroid. Let's see, I don't want the same points for large. Small asteroid points. And just pull that over a little bit. Okay, large asteroid. I want large asteroid points. Just gonna copy this. Oops, not cut. Yonk. Splat. There we go. And then we can mess around with these to make it a little bit bigger. Make the offsets just twice as big. Got 38 for some reason. It's 50, 44, 26, 27, this 20, 42, 38, 18, 40, 2. Something like that. Just as long as it's bigger. We can visually tell them apart. Then I'll do large astro points here. We'll spawn it at V2 like 400, 100. The largest didn't go? Why not? What did I call it? Did I call it big and small? Okay. That makes sense. Big. Yes, it's not terribly obvious because the folder stack uses its own kind of internal thing. And so I was thinking I think there's a command that tells you what the paths are and such. So that if you wanted to write a script or whatever to build that binary and upload it somewhere for your convenience, what have you, you should be able to do that. Okay, so large asteroid there's, we defined it. Now we can just add it to our array of asteroids. And we should be able to it should just get picked up and be rendered and ready for us to blow up. And there it is. There's our big one. There's our little one. Now the hitbox on our big one might be a little bit off. We might need to... I might have prematurely removed the hitbox rendering stuff. Let's just bring that code back in quickly first, just temporarily. Yeah. Render asteroid. Oops. Bring. Yes, kind of like that. Just without these marks here. Let's render those hitboxes again, just adjust that on the large asteroid. Yeah, so you can see the hitbox of the large asteroid is probably just a little bit too small for that. Just need to make it a little wider. Just a little taller, not much. Okay, so the hitbox stuff has collision box for asteroid. All right, so this is what defines the collision box. Now we need to like fix this equation here. So we need to actually case match, pattern match on the asteroid size. If it's small, then we return this collision box. If it's big, then we return a different collision box. Where we'll get the offset position as for the small one. Formula is going to be okay, a little bit different. It's going to be small offset position. And then we're going to need a large offset position. Or big offset position to be consistent. Asteroid position. So the V2 is the width and height. We want it to be quite a bit wider, so let's make it 60. And just a little bit taller. Let's make it like 55. See how that looks. Oh, and our big offset position, we have to define that first. It's 20, so we'll make it be 40. Let's just make it double it, make it 40. So the offset position, if you don't know, is because like SDL rectangles, the position of the rectangle is defined by like a position, which is the top left corner of the rectangle, and then a width and a height offset from that position. So if we take the asteroid's position, which is just the center of the asteroid, as the position for a hitbox, then the top left corner is going to be way off. So we have to kind of offset the part of the position of the collision box there. Okay, so that's compiling there. We're almost nailed it. Let's see. I think the position is just a little, the offset's just a little too much. Bring it, scooch it back a little bit. Scooch it back to 30. Rebuilt a little too soon. There we go. Okay, that's a little better. Still needs to be a bit wider though. Okay, so wider. 60 is not quite enough. Let's add 80. Okay, not too bad. Yeah, no, it needs to be a little bit offset more on the x-axis, I think. Just a little bit scooched that way. And then the height-wise, yeah, is pretty good. So it's not going to be just minus 30. So this minus 30 is on both elements of the position, which is a V2. So we're going to create a V2 where the first part be x minus, I want to scooch it over a little more, say 35, and the y element looked pretty good at minus 30. Of course, now I've messed things up. Loot. Oh, it's just a float. Oh, okay. Oh, ooh, what did I do with collision box? Collision box, collision box. Positions of V2 afloat. Yeah, that should be fine. Box size. Okay. Oh, okay, okay, yeah. We can't use fmap here, this function, anymore. Yeah, so the fmap thing is like reaching into each element of the asteroid position and applying the function big offset position. So if it's a V2, that's two elements, right? Two numbers inside the V2. But we're pulling apart the V2 and doing each element separately. We're not handling the same function, just so that I can scooch the X over a little bit differently from the Y. So we're just removing that. Okay, so let's move the X over just, yeah, the X should be 40 maybe. There we go. That's better. And then yeah, our hitbox can just be a little bit higher. So it could be like 60. Poor little silo box just wanted to be a little taller, that's all. There we go. That should feel pretty good. Not bad. Okay. Are we good with the code so far? Let's see. Oh, I gotta remove the game, the hitbox stuff first, actually. I might want to tweak the boxes later. Do I want to do conditional compilation stuff? Nah, we won't do it. But just so you know, Haskell, we have a way to do like C++ style macros or C style macros. Sort of. So you have access, you can basically do like this kind, it's kind of hacky, but it's kind of useful for in some cases. We can do we could run the C preprocessor over our Haskell code. This can be useful for doing things like if this platform is Windows, then include this extra Windows specific code. But if it's not, don't worry about it. It'll just ignore it and like remove that code. That kind of stuff. Can be useful for making libraries that are like very, very, very backwards compatible or like cross-compatible with a lot of different platforms. But for this project, we won't get into it. But I was thinking we could use something like that if we wanted to have like a debug build mode, where you could have, we could leave in this collision box detection rendering stuff just for debugging. Then we could just pass in a compiler flag that just activates our macro and adds that code in when the debug flag is set. But we'll just get rid of this. Okay, so let's just quickly review this code that we changed, that we made. So we added an asteroid size to our asteroid record. We changed the collision box instance so that we have different collision boxes for the different sizes. We added a large asteroid to our kind of scene, and that's it. So that's good. Stage, create a commit. Add big asteroids. So when applied this change adds a new asteroid size type for defining the kind asteroid. Kind of asteroid it is, I guess, to be English. And that's that. And with a large asteroid, sorry, a big asteroid. I get used to calling it a big asteroid. A big asteroid to the scene with a big asteroid and a hitbox. Boom. Okay, so now we have two different collision boxes for large and small asteroids. Now we can do, hopefully, we can check out spotting four smaller asteroids when we blow up a big asteroid. So for that, we're going to need some kind of like, we're going to have to update our collision detection code for the asteroid when it hits a bullet, or a bullet hits it. And as we may recall from a couple streams ago, when we were doing a lot of collision detection stuff, our collision detection code is nasty. It's not the greatest. So let's look at how we can do this. Check asteroid collisions. So this function takes the collection of asteroids and the collection of bullets, and we just do a brute force search through all of them. Not the most efficient way to do collision detection, but we don't need super efficiency here. We have a finite number of bullets we ever have in a scene at a time, and a finite number of asteroids. And we determine that the number of asteroids and bullets max in the worst case scenario is not big enough to worry about making a more efficient algorithm. We're just brute forcing it. Right, we're just checking every bullet against every asteroid to see if there's a collision. But now, when we check a collision, we're not just going to set the flag of whether, well, we just set the flag where it's dead or not. We now want to do different things with that asteroid once it is ready to be dead. So maybe we don't have to do anything in this code here. Because this just handles the bullet collisions, just tells us and sets the dead flag. We have another function that filters out the dead asteroids here that could do more. Right? Instead of just filtering out the asteroids, right, for the dead ones, we filter out, yeah, we should filter out the small asteroids that were destroyed that have the dead flag set. That's fine. But for any asteroids that are large that have the dead flag set, we need to add more asteroids. right? So maybe we could do that here, where it's not necessarily filtering the dead asteroids, it's just doing all the updates for all the dead asteroids. Because then we just return this collection of asteroids, right? But we can add, that doesn't mean we can only have to filter out. We can add stuff to it too. And become bigger. 0 or more asteroids are allowed to be returned here. Okay. Let's try that approach. That seems pretty reasonable. Okay, so before we filter over this, we want to do something else with it. What should that function be? Maybe what we want to do is fold over this instead of filter. Maybe that's the verb we want, the function we need. Can we fold over decks? I think so. I think they're foldable. So they have foldable. Yes, we get fold L, fold R, fold, and length. So when a type is an instance of something, I know there's some people following the stream tonight who are not too familiar with Haskell. The general gist of a class is that we give some functions to specific to a type. You can think of it like maybe, without explaining it too deeply, like some capabilities or some words you can use with a type. So foldable gives us the ability to fold map, fold from the right, fold from the left. And what fold is doing is basically going over each element and like kind of like an origami, you know, you're folding down a large sheet of paper into a smaller one, into a different structure. The same idea, how you fold over this data structure, combining it into a different one, into a different shape. We're going to be folding it back into a deck. We have a deck of asteroids. We're going to fold it into a deck of asteroids. But we're going to change the shape of the input deck to the output deck. We're going to do a little origami on it. What fold, I think, will permit us to do is that we can do the filter action. So we can check for that isAlive flag on the small type and just not add it to our accumulated deck that we're folding down to. And for the large case, we can do what we need to do for large asteroids. So this isn't the data.list fold that we want. Too few arguments, yeah. So fold L takes a function, an initial state. So we'll create an empty deck. And then the thing you want to fold over. Okay, so this hole here is our deck asteroid, and then our asteroid, and then our deck asteroid. That's the type it has to have. Just copy that. Maybe I'll leave isAlive there for now. Handle asteroid. So our function handle asteroid has to have this type. That's what the hole says. I'm going to do it. Put the hole there. And then I can put this up here. Okay. Cool. So when we have this hole now, all we have to do to get the type of the hole is deck asteroid to deck asteroid to deck asteroid to get rid of those. We want to get rid of those arrows. To get rid of those arrows, we need to bind them to something. So we're going to bind them as function arguments, right? The first is going to be A's. And then if I save this again, see the type again, we've got asteroid, we've got rid of one arrow, right? Now we're just asteroid to deck asteroids, so we can get A. And save it again. Now we have deck asteroids. So we're good here. Okay, so A's is going to be our what we're going to output, the asteroids we're going to accumulate into. New asteroids. Might be a better name to make that a little more clear. And the current asteroid we're looking at. Okay, so now in this hole we have to return a deck of asteroid. So what I'm gonna do here is we're gonna match on the one of the asteroids fields. Is it a big or a small? That's the first thing we need to do. So case asteroid size of asteroid. All right, so small, we already know what to do. Oh, not where, of. Big. So for small, we already know what to do. We just want to filter this asteroid out. If it's dead, we want to filter this asteroid out. Otherwise, we want to keep it. So let's introduce a guard here. Is alive asteroid. Otherwise, it's not. The asteroid is alive, we want to keep it. So we will accumulate it onto new asteroids. This is a fold left, so let's and this is a deck, so we can append to either side without any cost, unlike regular linked lists. So we can append this to the right, depending on what the function is. Snock. So Snock takes the A on that. So we'll take asteroid d.snock onto new asteroids. All right, that should satisfy that. Otherwise, it's a small asteroid. It's not alive. We don't want it anymore. We're not going to append it. We're just going to drop it. So we're going to just return new asteroids as is. Okay, big, we have a similar setup. We care first if it's alive. If it's big and it's alive, we should just accumulate it onto the end. Otherwise, it's dead. This is the special case we have now. This is where we need to spawn 4 more small asteroids. Excuse me there. So we need to spawn 4 more. What are we going to do? We could just add 4 more on for now, just to see that it does it right. Or just doesn't. So let's just do that. Let's just add 4 more asteroids onto our deck. And then we'll get to like spawning them properly and how we want to spawn them and stuff. So let's do, so we're not going to accumulate this asteroid, but we're going to do 4 new ones. Let's just do 4 new big ones. Yeah. Can we append? Can do Snox. Can we append a deck? Shift left. No, shift right, no. Filter, take, no. Uncons. Unsnock, no. Null, head, last tail, init. Nope. Okay. In that case, we'll have to convert our data structure so we can do this with something that can do these append operations. Or we're just going to continuously snock a whole bunch of. We're gonna have to snock a whole bunch of asteroids together. That could be fine too. We could probably do that too. That's not a problem. Let's do it that way. Okay, so we do new asteroids. All right, our first function is going to be snocking our asteroid. Yeah, so the whole here is an asteroid. So we'll do like asteroid where asteroid position. And we'll just hard code something ridiculous here, like V2. I don't know, 5, 5. And is dead is false. Asteroid is dead. Okay, and then Snock's going to return a new deck, which we can then snock onto again. Asteroid where the asteroid position is V2 88, 88. Let's just break this onto a couple of lines. And we want to make asteroid is dead false, just to be sure. Okay. It's not like 100% correct, but hopefully it's enough code that we can like just make it work. See that it's like we're kind of on the right path-ish. Okay, so let's go blow up this large asteroid and see 2 new asteroids spawn that are large. And they do. Okay, they spawn over here, but that's because we hard-coded them too. And then we can keep doing it and create lots of new asteroids. So we'll make them small asteroids too. That'll be a thing. Yes, start simple. Great advice, Swan Collective, and definitely what I recommend. I also recommend just going in as the smallest possible step you can make. Right? Test it, like get it to build, check it out, make sure it feels good, make sure it looks good, and then baby steps. And I think where you've seen me stumble, if you've been watching the stream for a while sometimes, is when I make too big of steps. right? And then I got to backtrack and be like, okay, how do we make this smaller? And it's much easier to manage that way. If you try to make too big of steps at once, you're just going to fall over. Try it in real life with your 2 feet. Same with programming. There's only so much you can do at once. So asteroid is dead, false. We'll make them small too. Asteroid size, right? It's kind of ugly code, but we'll fix it up later. Okay. Then we run it, we check it out, see what it looks like. Now they should spawn in as small ones. How? Oh, was I too happy on the trigger there? It's probably too happy on the run trigger, was I? I was kind of expecting them to spawn in as smalls. It looks like they're spawning in as larges. Oh, it's because the positions of the asteroid points are not changed as well. So it is spawning in as asteroid size small, but small doesn't determine the other parameter in the structure, which is the points. That's probably a deficiency of our data structure design, and kind of one of the reasons why I'm kind of mumbled that I didn't want to do, maybe we wouldn't, or I didn't want to use the constructor really necessarily, like the record constructor to create these, because the points we want to use really depends on this value here. Right, so we need to use like a smart constructor to say like, build me a small, and we'll hard code the points for a small. But you shouldn't have to define that with the asteroid. So that's why they're spawning in that way. But we know it works, so that's good enough. So why don't we go back and create that spawn function now. And then we can replace these terms in this expression here with our function and spawn in those new asteroids. And then, yeah, that'll be nice. That'll work. Let's go to our asteroid code up here. Okay, so let's make us a little function for spawn small asteroid. Or just spawn asteroid. All right, we're going to need an asteroid size. We're going to need a position, which is a v2 float. Yeah, we should probably set the initial velocity as well. And rotation, which is a float. Just the rotation speed should be good enough. And then we can return an asteroid. Right. So then we just have to fill in asteroid points. So this is why having this function will be much nicer. We can go here. We can based on the asteroid size we get as an input parameter, we can select which points we want to use. Right. Asteroid size. Or we could just call it size, position, velocity, and rotation speed. Right, presumably asteroid points of size. Right, so randomness, I'm going to get back to randomness. at some point. I have a strategy for working around that. Yeah. The code is kind of there. If you go to look at the repository, still kind of there. We're gonna get to it. We're just gonna hard code the spawning for now. But we can reintroduce randomness and pure randomness too. It'll be like pseudo random. So where was I? Yes, asteroid rotation. No, not that's update asteroid. Sorry, asteroid points of size. Right. Yes. Asteroid position. We can just pass in the one we get from our argument. The asteroid velocity as well will be initialized from the argument without any change. The actual, this value, we can hard code, it doesn't really matter. It's just the radians of the current rotation. For our purposes, I'm not too keen. We don't need to make that random right now. Ah, cool. Well, it's a few episodes back, but there is a bit of work on it a few streams ago. Yeah, we'll get into it again. So, no worries, no worries. And it'll be better when I get back into it again, because like, yeah, reasons. Smarter, wiser me in the future is better than silly past me who didn't know as much. So the rotation speed, yeah, we can give that back in from our arguments. Asteroid is dead is going to start spawn as false. The asteroid size is just going to be from our size argument. So then we just have to define asteroid points of, which we can define locally using a where here. And that'll be size. Asteroid size to asteroid points. So I'll use fancy schmancy lambda case statement to write this function. Small, big. We already have definitions for those in our init code, so I'm going to just steal those. Copy and paste them. Pop back over our hole. I got a parse error, so my popping back over is not working. Fix that. There. The small asteroids. It's just that. That's okay. I might need to enable that, yeah, that language extension. So lambda, that the slash case that I wrote is not default Haskell stuff. You have to enable it with an language extension called lambda case. And this is how you enable them. Okay, and then yes, that's right. Big float will be fine. And then big. I'll just borrow that. here? Oh, it didn't like me saying float, did it? Oh, V2 float. Okay. There we go. Cool. So we have a spawn asteroid function. That's great. We should be able to actually kind of use that in our init code. So we should be able to say small asteroid, spawn asteroid, small, V2 200, 200, V2 1.2, 1.2, 20, oh, sorry, 0.2, and that should be it. And the game should basically be exactly the same so far. Yeah, there we go. Pew pew. Pew pew. Okay, and so then we can replace large asteroid with a spawn asteroid call as well. Same arguments. 100, 1.2, 1.2, 0.2 rotation speed, and big. Large isn't a thing. I gotta remember to say big. For some reason, large is always the antonym to small in my brain. I don't know why I chose big. It was a bad idea. And then we don't need these defined here anymore. We can get rid of those. Made that a bit smaller. That was good. And then the real test is where we were doing filtered at asteroids. Now, instead of d.snocking this asteroid where, we change some elements of it. We can snock spawn asteroid call. And our position could be I think we have we can calculate this position as an offset from the asteroid that's dying. That's a pretty simple formula. Right, that would be something f mapped to change both elements, the x and the y, at the same time. The asteroid position of the asteroid that we're currently looking at. We have to give a couple more. We can even take the asteroid velocity vector, and we can take the asteroid rotation speed of the asteroid. Yeah, that's right. Yeah. Oh, I'm missing one. Position, velocity, rotation speed, size, position, velocity, rotation speed. Ah, yeah. small. That was the whole point of the exercise. Okay, there we go. All right, so we just have to have a function float to float. One such function could be like minus 10. Oh, it's... Oh, the Haskell and the syntax of this might be a little bit weird. Plus negative 10, would that work? Yeah, okay. That formula looks a little weird, but we can basically add negative 10 to each element of the asteroid position. So if we had a point at 2020, or say 2525, all right, beep, 2525, this expression here will be applied to each element to create a new V2. So plus minus 10. So adding minus 10 to 25 is 15, 15. So you'll get like a point somewhere up here, 15, 15. I know it's pretty basic stuff, but a little review for you. Okay, so let's replace this one with a similar call, but we'll just add 10. And actually be able to type this out properly. Okay, and so now when this compiles, we should see it spawn 2 small asteroids. And they should actually be offset from the position of the big asteroid that gets blown up. And there we go. Pew, pew. Pew. Total of 4 there. So not spawning in random ones yet, but we're blowing up the big ones, and that's what should happen there. Yeah. I do. I have the highest score that's ever been scored in this game. I am the record title holder in Asteroids. Okay, so we're kind of at the end of the time that I have for the stream this week, but let's get this code committed, and then next week we'll clean it up, and we'll get spawning working better for large asteroids, so that these all spawn in the right positions. And then maybe we'll add the randomness stuff back in so that yeah, we can spawn in new asteroids in different places as the game progresses. Yeah, so we'll do that. Yeah, the thing we have to do here is we have to change, like, we have to spawn 4 in at different offsets, and then we'll also do the velocity math so that they all kind of explode outwards, and that'll take care of that. And yeah, and then we'll do randomness. We'll introduce randomness back in. So if you do want to take a peek at that ahead of next week's stream, by the way, it's in the random file here. I'm not sure we're going to stick with this implementation, but we've wrapped up this idea behind a data structure so that we can change its implementation under the hood without anybody noticing that uses the interface. So hopefully it won't be too much to change, but the idea is we might even not even need this. Like, the random library is actually pretty good and has ways of doing this without doing it in I/O, everything in I/O, which is kind of what I was going for with this design here. But yeah, the idea is you can initialize one of these once in I/O, and then you can pass it around, and then you just have pure functions to get random numbers out of it. So you only generate a certain number of random numbers at the beginning, And you generate them all at once off of a seed. And then you just cycle through the list of numbers as you just pick one out. Okay, so it's not like perfectly distributed randomness, but it's like probably good enough. And then you don't have to deal with, you know, calling out to an actual random generator outside of your program, which is an I/O effect, and as we know, that can leak into your program all over the place and blah blah blah. It's just, don't want that. So, yeah, we'll work on this a little bit to be able to reintroduce it back into the game so that we can spawn them. We can have a spawn random asteroid, for example, function, that kind of thing. So. Cool. Thanks for tuning in this week. If you like what you saw and you want to follow me and get notifications when I go online, because sometimes I do streams off my regular schedule, you know, click the follow button there. And if you're watching this on YouTube, because you're in a different time zone from me, no worries. You know what to do there. I do normally do these streams for those who are just watching for the first time this week, once a week on Tuesday evenings at 10 after 8 in the Eastern time zone. So tune in there. And you'll see me once a week, and we'll continue working on this project and others. And you can follow me on the socials. Of course, I am Agent Ultra in most of the places. If you want the code from this project that we worked on tonight, it is on GitHub. Let's just commit this add spawn asteroid function. Push that up. That can be found here. Agent Ultra / Asteroids on GitHubs. And you can find our code here. So check that out. I'm also on the Fediverse, the Mastodons. I like Homestar Runner. Big fan. And you can find me Agent Ultra at TypesPL. And yeah, that's what we got for this week. So thanks again for watching. It's been real. May your monads always be free and your types always check, and we'll see you hopefully next week. Take care.